So exponent properties we can cover so many times in a year, and yet we seem to struggle anyway when it comes to them. So here's something that you can watch over and over again. So first off, we have 3 rules today that we're going to go over. The first one is, what if you have the same base being multiplied? Well, then what's going to happen is you are going to add the exponents. So this will be a to the m plus n. Okay? So if we look at this example here, I have 3 times 3, that's the same base being multiplied, so I need to add my exponents. Now you'll notice that first 3 doesn't have an exponent, so I'm going to put a 1 there, because you can always put a 1 for an exponent. And so I get 1 plus 5 is 6, so it's 3 to the 6, which you would want to plug into a calculator to figure out what it is. Okay, for the next example, I have actually 3 bases being multiplied, and so I just add all 3 of them. I take 2 plus 3 plus 4, and I get x to the 10th. And that would be my answer, because since I don't know what x is, I can't use a calculator. So for your next rule, we have where you have the base being raised to an exponent, and then that's being raised to another exponent. And so when this happens, your job is to multiply those exponents. Okay, so here I have an example. I have 3 to the 5th squared, so I'm going to multiply the exponents because I'm raising exponent to another exponent, and I get 3 to the 10th, which of course you'd put on a calculator and figure out what it is. Third rule today, we have if you have 2 different bases being multiplied and they're both being raised to an exponent. I can tell they're both being raised to an exponent because they're both inside the parentheses. So when that happens, what you're going to do is you are going to distribute that exponent to both of them, and this only happens if it's being multiplied. If there's an addition sign there, you cannot distribute the exponent, you'll just leave it alone. So we have a to the m times b to the m, and that would be your answer. So let's look at our first example. Notice I have 3 things inside the bubble being multiplied. So all 3 things get the exponent, including the 4. The 4 and the y are not connected. It's being multiplied just like everything else. So this would be 4 to the 3rd times y to the 3rd times z to the 3rd. And then your final step is to figure out what is 4 to the 3rd, and then just write down the y to the 3rd and z to the 3rd. Okay, on our next example I have -2. Now that negative, look at that negative as being part of that 2. So we have -2 squared and w squared. So we get -2 squared and w squared. And then -2 squared, that would be positive 4, because the negative is squared also, and then w squared. Okay, so those are those in a nutshell. Now let's look at what it would be when they're all over the place and doing all kinds of stuff. So the first thing I see is that we have this bubble here being raised to an exponent, and usually when you have a bubble, that's the first thing you want to deal with. So I'm going to distribute my exponent to all 3 things. So now I have 4 to the 3rd, I have x squared to the 3rd, and I have y to the 3rd, and then I still have that x to the 5th on the side there. Okay, now I look at this as being a whole new problem, and I see that I have this being raised to another exponent. So remember, I'm going to multiply those exponents. 4 to the 3rd, by the way, is 64, and then I get x to the 2 times 3 is 6, y to the 3rd, x to the 5th. Okay, now I don't have any more bubbles, so I don't have to worry about those. But I do see that I have 2 x's. They're being multiplied, and I can switch orders, so I can put those together if I want. And they're being multiplied, and so I add the exponents. Now I have 64, x to the, add the exponents, 6 plus 5 is 11, and then y to the 3rd. Okay, now as I look at this, I'm pretty sure I'm done. I have only 1 x and 1 y, so I don't need to worry about putting x's and y's together. And I have only 1 number, so I can't do any multiplying or dividing or anything like that. So this is my answer for this one.